Okay, so unlike linear systems, systems of inequalities can have numerous inequalities. And let me explain that a little bit, because we can have numerous equations in a system as long as the number of equations is the same as the number of variables. So if I have 4 variables, I have to have 4 equations. In this case though, I don't have to have that. Okay, I could have a y is bigger than 0 also, and I could have them all over the place. Okay, so let's look at this one and see what happens. So for this top one, I'm going to treat it like y equals 2x plus 1. So my y-intercept is 1. I forgot to set my timer. Okay, and then my slope is 2, so up 2 over 1. And it's a solid line because it is a greater than or equal to. And again, I'm going to test 0, 0, which is right here. So is 0, if I plug this in, 0 plus 1 greater than 0? Is 1 bigger than 0? Yes. So that means that this point right here is in, I'm just going to do this time. That means that that point is in my solution set. Okay. X is less than 5. Let's do that one. That one's pretty easy. So X, I put my boundary line. Okay, I draw a line at X is 5, and it's going to be dotted. Okay, so, and I know that 0 is less than 5, so that means that all of this, from here on out, all of that. Okay, and finally, our last one, we've got y is less than x plus 2, so I've got 2, and the slope is 1, and it's less than, so again, this is going to be a dotted line. Make sure I got it on here. Okay. Okay, so I've got a dotted line. Is 0 part of this one? So let me see. Is 0 less than 2? So is 0 less than 0 plus 2? And it is, so 0 is included in this one too. So that means everything on this side of the line. So hopefully you can see where it's overlapping, okay? So it's everything from here to here to here and down. So this is all of where it's overlapping. Okay. Next of all, and this will be our last example. Next of all, we have one that has 4. Now luckily, whenever you have x is greater than 0, or x is greater than or equal to 0, and y is greater than or equal to 0, this is when we're dealing with the first quadrant. So that's nice. We have an automatic, not limit, border. Automatic border right here and an automatic border down here. All right, so let's graph these. I'm going to turn this into a line again. So 3y is, well, I'll keep it as an inequality. Less than or equal to x plus 15 divided by 3. So my border is going to be y equals 1/3 x plus 5. So here's 5, up 1 over 3. And it is going to be, all of these are solid lines. Whoa. Okay, so there's that one. And it's really important on these that we get them just right, because I'm going to show you something. Okay, and then down here, I'm going to do y is less than or equal to negative 2x plus 12. So 12 is the y-intercept here. I'm going to go down 2 over 1 is my slope. And again, it's a solid line because it's less than or equal to. Okay. All right. And when we look at these, I guess I forgot to do the shading. For this one, we have is 0 less than or equal to 0 plus 5, and it is. So this is going down like this, all the way up that way. And this one is 0 less than or equal to 0 plus 12, and it is. So basically what I have right here is this polygon, okay? All of this thing right here, all filled in. Okay, and on your homework, and this deals more with just based on the word, linear programming. When we talk about optimization in linear programming, what you have to know is all of the vertices. So in the homework, it asks you to write down each vertex. So I have, on this problem, I have 0, 0, I have 0, 5, I have 6, 0, and I have 3, 6. So on the back page of that, worksheet, they're going to ask you to do that. Okay. The rest of that is all linear programming, and your homework is just that worksheet. So let me know if you have any questions.